the subsequent tutorial in the Athena tutorials, which I believe is the Orszag-Tang vortex problem. But let's take a look. So we're going to Google, or in this case, Brave search Athena tutorial MHD. Click on this princetonuniversity.github.io/AthenaC version. Click on the documentation link. Get over to the tutorial 2D MHD Orszag-Tang vortex. That's right. All right, so we're going to open our terminal. We're going to use our aliased SSH command to connect to our remote machine. We're going to cd into our change directory into the Athena stuff directory. We're going to change into Athena 4.2 directory, and then we're going to issue some of these commands. Make clean /configure with problem. It's probably better to just copy paste this part, to be honest, to avoid making typos. I'll see if I make any. It's also just a little bit faster probably. And then make all. Then make all once again does not work. We have to edit our make options, set machine equal to Kraken. Try make all again. And now it is compiling. It'll take a moment or so. Yeah, so aside from just running through this tutorial, I'm going to cover how to plot using YT, which is a astrophysics analysis and visualization package in Python. All right, so we did make all. So I typed the up arrow to look at the last command. And now we're going to cd bin /Athena-I /test. I'm using tab completion to, for one thing, avoid making typos, and for the other thing, to type less. Now that does use the pinky, which is a weaker finger. So there's a bit of a trade-off there between typing less and using, and more of using one of the external appendages. Okay, we're gonna let this run. Looks like it's gonna go 656 cycles. So yeah, this is a bit more expensive since it is a magnetohydrodynamics problem, and it's two-dimensional, whereas the last problem we did was one-dimensional. And so this will just take a couple of moments. It's gonna keep on spitting out. So this is the cycle that it's working on. Kind of behind the scenes for each of these cycles, it will basically construct the Riemann problem. It will solve for the fluxes across that interface. It'll then update based on the physics that's going on, including MHD, or basically including magnetic fields, and solving the Navier-Stokes equations, or well, modifying the Navier-Stokes equations to include Maxwell's equations. Does add a significant amount of overhead. Second column here is the time, this isn't code units, the sort of normalized time of the simulation. Next dt corresponds to the time step, so the change between the current time and the next time that the simulation is going to evolve the following step for. And then this last dt is showing what the previous one was. All right, and so we got a bunch of info. Looks good. It's probably not going to match this exactly, although the file density looks pretty similar, within maybe a few percent. All right, and so when that's done, it's going to recommend using image magic, which is pretty nice. I really like using image magic. So let's try animate star.d.ppm. That doesn't look so good. Okay, so used Control-C to exit. And yeah, there are indeed a lot of these ppm files. I'm not really sure what file format that is. And then, so that didn't work so well, but in any case, and then they recommend using IDL. I probably don't have IDL in here. There might be a module for IDL, but you need a license to use IDL, so I'm just gonna move ahead with the plan to use YT at this point. Import YT, and sweet, that's actually included. Depending on what remote machine you're using, you might need to load a Anaconda Python module or do a local install of YT. But in our case, it's already there, which is pretty sweet. And then I'm going to, not do this from the command line. That was just useful to test whether it was installed or not. So I'm going to write a plot.py script. So the first line, I guess, will be import YT. Also going to import the OS package, glob, and numpy. So these are included with Python. You typically have to install. You come with most like Anaconda, most packages these days, but aren't guaranteed to come with it. So we're gonna do grab our files, do np.sort glob of star.d.ppm, and we're gonna loop over all of these files. So we're gonna use the Python enumerate function, which says that not only do I want to know the index in the loop that I am, but also spit out the file in that, or not just the file, but whatever variable in that loop we are. Enumerate f's, and then we're going to do a yt.load fn. This ds stands for data set. We're going to do a slice plot. So yt.sliceplot. We're going to use our data set that we just loaded. Going to slice through the z-axis. So this was a 2D problem. So z-axis slice should be just giving us our xy data. We're going to plot the density. And then we're going to do slc.save. And so this for loop just lets us do that for every file. And plot.py. And then this is going to take a few moments to run through this. And that did not work. Could not determine input format from ppm. Okay. Yeah, I'm not really honestly sure what that is either. So let's take a look. Some sort of text file. So I'm gonna make my window a bit bigger. Oh boy. Okay, it's not a text file. Some sort of binary. All right. So I think it would be more useful to actually jump into the input file at this point. So I'm going to copy from test 2D MHD at the input, and we're going to modify this now, modify it locally. So there's a couple things. There's this comment thing, which just gives us some information, doesn't really affect the problem. It's the job, so this problem ID specifies the output base name. There's max out, which is the number of output blocks that are read. So the output 1, 2, 3, 4. So if I set this to only 2, it'd only read the first 2. I'd ignore the subsequent ones. Number of domains. And then, the output format. So this is where instead of ppm, I'm going to switch to VTK. I apologize for all the background noise now, but I guess someone decided to start up their own little symphony in the music room next door. Okay, and so we have, so I need to remind myself the structure of this for specifying VTK is. It's probably a little bit different than the ppm. So, right, I'm going to SSH again. Going to go into Athena stuff, Athena 4.2. Going to take a look at, I'm going to go look in test. and then some other. I'll try 2D hydro and look at the input for Kelvin Helmholtz maybe. And I'm not even sure what output format. This is also ppm. Yeah. Theoretically it's fine, but I don't know how to handle ppm files. Alright, so we're gonna try VTK. Yeah, I'm gonna go to actually a different cluster. Look at the version of the code that is a little bit, let's see. Yeah, so I'm going to use my supervisor, my fork of my supervisor's fork. And then look in runs. Yeah, okay. I'm trying to remember where I put the input file. Oh, right, it's where I'm actually running stuff. So if I look at input, then there is a VTK and we just output all the primitive variables. So that sounds good. So yeah, out is going to be prim. So instead of just the pressure, just the density, we're going to just output all the primitive variables. And then for dt, we'll still keep it at 0.004. And then we'll remove, so I'm typing dd, d once and then d twice, delete the line. And then we don't need this fourth output block at all. I guess they must do some plotting, which is why it says to, which is why they just did the animate command. And then we're going to set max out to 3. Remove startup ppm. Remove startup bin. Just to do a little cleanup. Remove, oh yeah. Remove sod star tab. And let's see, remove star.hst. And then that should be good. We'll remove test.png as well as plot.py. Plot.py is what we just wrote. Yeah, so we'll leave that. And now we'll do Athena-I, and then we'll use the ath input in our current working directory. And then this is going to take a few moments again. While it's doing that, I'll close the door. All right. Yeah, and so one could make this a little bit faster by using multiple cores. And oh, I should mention that for most clusters, so this is actually not really a cluster. It's kind of hard to explain. I mean, it's a remote connection, but it's actually to, yeah, I mean, it's to a login node, but for some reason they don't care about people doing up to 40 processes. Or maybe it's up to 10 processes on the login nodes, which is kind of weird, but it handles it pretty well. There's not a ton of people here, so I guess it makes sense. Most, large clusters where there are thousands of users, they really don't want people abusing the login nodes. And so for all this stuff, you'd want to use a slurm command, which is what we will get to at some point. Not necessarily slurm, just use some batch scheduler. Okay. But we'll talk about that later. So that's done now. And so we have all these, still a lot of bin files, a lot of VTK files. And now if we go into plot.py, so now the extension is different. So do star.vtk. And now we'll see if YT can handle VTK file formats. I don't actually know what VTK is. I just know that Athena likes to make VTK files. I actually prefer HDF5, and we'll switch to that at some point. But for the tutorials, at least, I guess VTK is fine, especially since all this is in serial. And so, yeah, this is spitting out a lot of junk. Main thing is that YT gives you a lot of info and a couple warnings whenever it reads one of those files. So this is, I think, primarily coming from the load. Maybe some of this is from the actual slice plot. And so this is going to do this, I don't remember, like 600 times. It's probably, so there are 656 steps. How many? So this is from Freya. Let's go back to serve 14 Athena, back to bin. And there's 250 of them. So it's going to do this 250 times. So that's kind of slow. So let's just kill this. So I typed Control C to terminate. And so it did 26 of them. That's not bad. But I'm going to, I'm actually not sure that this is going to work, but we'll try it. So with YT is pretty nice because it makes parallelism really easy. At least on your local machine, it makes it really easy. On a cluster, again, typically you should do everything through the job scheduler. So I'm not sure if this will work. And it's actually like a very similar format. I don't think I can enumerate as easily though. I'm just going to do yt.parallel objects, and then this tells parallel objects, I believe it's plural. And so this, so YT just kind of handles everything for you and says for each processor, you know, they get divvied up their set of Fs, their set of files, and then we loop through here. I'm going to print the file name so that we know that stuff is going on. And then the other thing that's nice to do is to suppress all that junk output. So from yt.funcs, import mylog, it might be singular, and mylog.set semicolon, mylog.set level 50. And then we got through the 26th one, so we'll do from 27 forward. That's going to repeat because of the 0 index, but I guess that's fine. Oh, this is still going to just do one of them because I didn't tell it to like use multiple cores. That's not too slow. But yeah, instead of just doing, so this is still just going to use one core, but if I do mpi run dash np4 python 3 plot.py, it should use 4 cores. And yes-ish, except just spat out that mpi4 pi was not found, so it's actually just repeating the exact same thing 4 times, which is not helpful. So I'm going to Control C to kill that. And then how many PNGs are we at? We're at 32 now. So that's the other thing I forgot to do, is I should probably tell this to start a bit higher. And then do Python 3 import mpi4 pi, not found. All right, so now we'll talk about the module system a little bit. So my current modules that I have loaded are just TechLive and whatever the defaults are, which I guess include YT and Matplotlib. It could be bash RC. It could be that I already have. No, it looks like this is pretty defaulty. So that's nice, but we don't have mpi4 pi. So I can try. There are different commands on different systems for finding stuff. I'll try module spider Python. Nope. I don't even remember how to do this. Module, you'd think it would be like module find, but it's never that simple. Yeah, I don't even remember. All right, so we're gonna go to module find. Might have to, so this is the Slurm schedule, like, well, Slurm's the job scheduler. I'm not sure if it's the batch system. That's not related, unfortunately. So I'm gonna type Freya user guide pcdf. This is not Freya, but I think it'll be similar enough. And hopefully they mention how to do stuff with the modules. Not that I quickly saw. And unfortunately, documentation is pretty sparse here. Okay, yeah, I'm trying to remember how to, okay, there we go. So if you just type module, it defaults to module help. So yeah, that's the other thing, is usually there's some sort of help command. There we go. All right, so module list shows what's already loaded, module display. Module avail sounds possibly useful. Module avail Python. That's not quite what I'm looking for. Module apropos Python. Might be it. Alright, so I think I have my old bash RC, in which I load a couple of things. I probably just need OpenMPI, maybe. Gonna look, I'm gonna do a little cheating, and yeah, alright, so I'm gonna make this a little bit easier on myself, and well, I'll just explain it, I guess. So in my old bash RC, I have a lot of useful aliases. I'm going to grab this alias CDS, so it just aliases a change directory to the scratch space, which I don't think is set up on this system, which is too bad, but a lot of them have different helper variables set up to help you navigate. And so my simplified bash RC, which I've built through this tutorial, I'm going to add that. I type bash, so it reloads it. Then I can CDS, and then I have just, I've done a lot of stuff before. And so I'm going to cheat a little bit, look in script repository, look at one of my Slurm files. That's not the most useful one. This one includes some analysis. So yeah, there's a module load MPI 4pi. So module apropos MPI 4pi. Usually documentation is a little bit better, which lets you look for things on a website, but sometimes you're stuck with the terminal. And okay, so I did module apropos MPI 4pi, spat out a bunch of garbage for the most part. So yeah, that's still not, I think, the command that I want. It helps find stuff. Maybe module avail. I think I tried that already. Yeah, a bunch of garbage. I don't know how you find stuff with this thing. With Michigan's cluster, it's a lot easier, but okay, well, I found it once upon a time. So we'll do module load MPI 4pi. Well, that's fun. Maybe that's only on Freya then. That's probably only on Freya. Well, that's fine. Alright, well, might be stuck without parallel plotting in that case for this cluster. I mean, there's definitely, there's gotta be something. I'm pretty sure I've plotted in parallel before. Maybe I just need, I probably need to load MPI, like some form of MPI. So we'll try this first. Oops. Module load OpenMPI Intel. Cannot be loaded due to missing prereq. Needs Intel. Okay, fine. So first module load Intel. Then we'll module load OpenMPI Intel. Then we're gonna try. We're not using HDF5 now, but we'll use it later. And so these are in my old bash RC, so we'll actually add these to the new one so that they're always loaded whenever a new shell, or a new bash shell anyway, is loaded. Okay, so we loaded all that stuff. We can check that that was successful by doing module list. Now if I do, I don't know if I want Python 2 or Python 3. So this is Python 2, port MPI 4pi, not found. If I do Python 2, nope. Oh, it didn't. Interesting. So I think I need to. I need to unload this? Let's go check in the old bash RC if I purge or not. I don't purge. No, I don't purge. So module purge just removes everything that you've loaded. It unloads everything. I don't remember if I module loaded HD5. I think I did though, I did. Alright, I think that this is conflicting because, I mean, I tried loading this and it didn't load it. So we'll do module unload and then what I just copied, and then we're gonna try this command again. She uses Python 2, which is a little gross, but okay, that's fun. Might have been because I had a space where I wasn't supposed to have a space. Yeah, it's not doing that at all. Okay, well, unfortunate, but I guess maybe you just can't use MPI4Pi on this cluster. Or you can probably do a local install, but that's definitely too much work. So in any case, maybe you just have to be a little patient, which I'm not, in terms of, you know, generating all 250 image files. So far we have 32 of them. So I'm just going to run this. Yeah, so we're going to remove the yt.enable parallelism. We'll put it back in. Whoops. So if you do Q exclamation mark, that doesn't save. Just all right. So we'll leave it in, but we'll just do it in serial. Then rather than wait for that, we're also going to animate kind of while it's doing that. All right, so we're here. All right, so we have some image files already, and yeah, actually maybe we won't make those into a movie. Maybe what we'll we'll try it. Animate star.png. Use ImageMagic's animate command to show a movie. And maybe that's working. Doesn't look good though. Could be that I sliced improperly. I don't know for sure though. Close that. All right. So we're gonna use display, which is another ImageMagic command actually. 0044 slice z density. And yeah, that looks fine. So there's just some issue with animate. All right. So I'm gonna use the file command, which is another thing from ImageMagic. ImageMagic is a really nice package. So this has odd numbered. Says odd shaped, and FFmpeg really hates that. So I'm gonna grab. I'm gonna cheat again. No. All right, bash cds. I'm gonna go into my research environment and grab script repository, make even dim.bash. So this is a bash script which loops over PNGs in a given plot directory, and then basically it just, you know, cuts off like a single pixel along the dimension that is it has an odd shape, and if it doesn't have an odd shape, then it leaves it alone. And this uses ImageMagic's convert command with a resize option. Okay, so I'm just gonna copy that and not walk through making it. Let's see, so back into the bin directory, and the way I have this set up, it wants to, so this convert bash, make even dim.bash, it wants to know where you are, so I'm just gonna pass money pwd, so my present working directory, and I should probably echo like which file I'm working on, but it just looped through all of them, that's why it took a moment. I don't have any output in there, which is why it was silent, so it's not even clear. So at the very least I should say like success, echo success, like here, echo success. Now if I run this command again, I think that was a bit faster because everything was already even, so I can check that. Orszag-Tang. Actually, there are probably new files that it was working on, because the plotting script is still working on everything. All right, 44, for example. And so this is even dimension now, so great. All right, and then I'm also gonna cheat and grab my animate script, which is really just a Python wrapper around FFmpeg, but I can never remember what the options I like are. So research environment, script repository, CP, animator, animate. All right, so copy that over. Yeah, so we ran into a couple of problems this time, but that's okay. Maybe it's useful to see what happens when problems get run into. So basically, usually you have some documentation, which is nice and tells you what the modules are, and or you end up just spending a little bit more time going through the module help and then just figure it out eventually. But because I've already done this, I didn't want to spend a lot of time banging my head against the wall with it. Okay, so this animator script, I don't know, it's not too fancy. The main thing is I want probably just set frame rate, which I need as a string the way I wrote this, to set to 30. Probably 60 frames per second is good when we have all 250 of them. Maybe that'd be too quick even. All right, and then the main thing here is we do a FFmpeg command, which stitches all the PNGs together and makes an MP4 out of them. Oops. Yeah, so it's important when exiting VI. So the W is to save, Q is to quit. Those need to be lowercase. So that happened because I accidentally hit my caps lock key. Usually I disable my caps lock key, but this laptop is new and I haven't done it yet. That didn't work. All right, so this is probably looking for, it's looking for PLT-CNTs, which are flash. So just glob for star.png, Python animator, still empty. Okay, well, we'll actually write out so I'm gonna connect again. I need to enter my 2FA at this point. 422, although, it changes every 60 seconds, so not that knowing that matters. And I'm not going to be uploading this for a little while, at least not until it's done. So we're going to go back on over there. All right, and then, so I'm just going to, maybe I'll read from it here. It doesn't really matter too much. But we're going to do ffmpeg from the command line. First, let's see if it knows about ffmpeg. Yep, it knows about ffmpeg, which is great. And then we're going to do -y and frame. Was that dash frame rate? Yeah, dash frame rate. And then we're going to do 30. And then -I, that's for input, and we need the name of the files. I wonder if my file name structure is not nice enough for ffmpeg. No, that should be fine. All right, so I just need this part. That's like the base name that I have defined over here. So base name plus motto for D. So this is saying that there's, this could be quadruple zeros, could be triple 01, could be 0091, etc. And then we need the extension, or just kind of the rest of the name. Okay. And then let's see what else this wants. And then a -pix format, YUV 420p. I don't remember what any of this stuff does, honestly. And then the output file name. So I'll just call it ot.mp4. Fun, what happened? FFmpeg. Looks fine as far as I can see. Error while opening encoder. Could be because of, we'll try copying vector images, copy startup PNG into images, and then we'll CD into images. It's almost, the plotting script is almost done now, actually. So we'll do ffmpeg dash y dash frame rate 30. Need a dash I command again. Mod 03. Maybe this needs to be a 4. It does. Well, it should be a 4. Add 4D. And then, oh, I think I included I might have forgotten the dot before, which would explain why I was unhappy. And then dash pix format without a dash yov 420p. Oh yeah, I forgot to say OTMP4. Dang. All right, well, I'm not sure what's wrong at the moment. Possibly it doesn't like the file format. So what we're going to do is we're just going to copy the, oh, fun. That's a memory error. Maybe maybe I'm just doing too much. So we're just going to copy those image files, which are here as well as in that images directory. We're just going to copy those to the local machine. So we're going to exit out of there. We're going to go to SCP, received files, vi SCP from mpa.bash. I'm going to change this file path to just do star.png. So the star is a wildcard saying anything, and then you're requiring that it ends in .png. And we're going to copy it here, which is going to be a little messy, but that's okay. I need a 2FA. I need my password. Okay, so it's copying all those files. And I look in my Finder and go over to received files. Then we can see, so initially, so YT does something a little funny when it has a uniform field. It causes, I don't know why, but it does all this like grid stuff. And then if we look moving forward, can step through. And so this color bar is not fixed, and so it might be nice to fix that. But we can see that it's, so there's initially a uniform density field, but because there are a couple of magnetic vortices, which you don't initially notice in the density field, it ends up kind of churning the fluid around. And this is called the Orszag vortex. I'll include a Wikipedia link to it if you want to read more. So this is kind of lowish resolution. You can see the pixels. Kind of like the look of the pixels aesthetically. And then when we're stepping through, I think we're almost through as many images that we generated. And yeah, it'd be nice to, so usually use FFmpeg. I mean, you can use just some, I guess, web app to convert PNGs into movie file format, but maybe we'll get that figured out next time, because I think this video is pretty long. Okay, see ya.